Welcome to Integration by Substitution practice problems. These are problems with solutions that range from simple to challenging. Now, when I say challenging, there'll be twists to the last 5 problems, and every twist is different. To say one type is harder than the other is an individual thing. Each person finds something different challenging. So, integration by substitution is a technique for finding antiderivatives where the derivative involves a composite function. The presentation for integration by substitution is covered in my other video, and here's the link. If you're not familiar with the technique, I would recommend you go there first and then come back. This is the practice set. Feel free to refer to it at any time. I think you can actually have them both open simultaneously, but I'm not sure about that. First, a few words about this video or in order. You will find 10 problems. After each problem will be a detailed solution. I strongly feel that students need to identify whether they are practicing correctly. Practice of erroneous techniques reinforces the errors. It is also important to try a problem before looking at the solution. Seeing the solution can lead to a false belief that the problem has been understood. So try the problem before looking at the solutions. When I was teaching, students would often ask me to do the homework problems before they would do. They would have the answers, and they couldn't figure out how to get to them. I would not work that problem on the board till the problems would due, because that would spoil the problem for the rest of the class. So I have the solutions so that only one will appear at a time, and it will be right behind the problem. So as I read through the problem, is the time for you to pause if you're going to practice and go look at the answer after you have tried. And it will be a detailed answer. Calculus is understanding. What presents the challenges of calculus is the algebra and trig appearing in random order and not always in a familiar manner. Be ready to think outside the box. So when we get to the last 5 problems, it will ask you not only to do the calculus, but it may have something to do with algebra or trig. Okay, the first problem. F of x equals x over the cube root of x squared plus 1. Find the integral of x over the cube root of x squared plus 1 dx. Now, for this first one, I'm going to remind you the answer is about to appear. So in this problem, we'll let u be x squared plus 1. du is 2x dx. So you'll notice that I don't have 2. I have the x dx. What I would do is multiply by 1 in the form of 2 over 2. And the first 2 is going to be involved in the u and the du, and the second 2 will be remaining for the denominator in this case. So this is going to be 1 over the cube root of u, which is u to the minus 1/3, du over 2. So we would integrate a power function, 3u to the 2/3 over 4. So what we're going to do is have the divide by 2/3, and that flips up to 3 over 2. 2 times 2 is 4. plus the constant of integration. And we would always substitute back because we want an answer in terms of x. So this is going to be 3x squared plus 1 to 2/3 over 4 plus c. This one was fairly straightforward with the exception of having to multiply by that 1 in the form of 2 over 2. But that's very standard and something you should always be ready to do. The next one, f of x equals x cosine x squared. Find the integral of x cosine x squared dx. Well, the obvious choice for you is x squared because I can see its derivative, x dx, missing the 2 again. But so I make u x squared, du is 2x dx. Again, I'm going to have to divide by 2. So the integral of x cosine x squared dx equals the integral of cosine x over 2 du. Well, the integral of the cosine is negative the sine, so this becomes negative sine u over 2 plus c, which is negative sine x squared over 2 plus c. To make it clear, this exponent goes with the x, with the sign. Our third problem, f of x equals x squared e to the x cubed minus 1. I'll find the integral of x squared e to the x cubed minus 1 dx. Well, if we let x cubed minus 1 be u, it would work. Or if we let e to the x cubed minus 1 be u, it would work. So here we have a choice, and to be honest with you, it really is a preference. Finding u is not a forced issue, so we can't force u. Sometimes we have more than one that will work. I chose to let u be e to the x cubed minus 1. The derivative of that, d, is 3x squared e to the x cubed minus 1. So it would be e to something is e to something. And the derivative of x cubed minus 1 is 3x squared plus 0, because the derivative of the constant is 0. So I have du equals 3x squared e to the x cubed minus 1 dx. So now I'm going to integrate this. The only thing is, here I have this 3, so I have to multiply by 3 over 3, and everything is in du. The integral of 1 du, or in this case 1/3 du, is allowed. So everything can be gone except for du. So this is going to be the integral of du is going to be u, and that's going to be e to the x cubed minus 1. And here's the division by 3 still, plus the constant of integration. So here we did have a choice. Some of you would prefer the other possibility. Number 4, f of x is 1 over x plus 3. Find the integral of 1 over x plus 3 dx. Well, if I recognize the integral of 1 over x, is a log, I'm going to let u be x plus 3, and du, in this case, is 1 dx. And yes, that is allowed. Du can just be dx. So now I have the integral of 1 over x plus 3 dx is the integral of 1 over u du, and that is the logarithm of the absolute value of u plus c, which is the logarithm of the absolute value of x plus 3 plus c. Of course, x cannot be negative 3 because that would cause a problem here, and it would cause a problem here. So we're assuming here that things are all defined. Number 5, the integral of 2x over x squared plus 1. Find the integral 2x over x squared plus 1 dx. Right. So I'm going to let u be x squared plus 1, because I can see the derivative of u is 2x dx. So I have the integral of 1 over u again, du, and that's going to be the logarithm of 2 plus c, which is the logarithm of the absolute value of x squared plus 1 plus c. In this case, the absolute value bars are not needed because x squared must be 0 or larger, and so x squared plus 1 is always positive. But get used to putting them, and that way when you need them, they will be there. Okay, now we're going to start with some fun. F of x equals 1 over x squared plus 2x plus 1. Find the integral of 1 over x squared plus 2x plus 1 dx. You may want to give some thought to this one, but it's not really that hard. Again, I'm going to point out that algebra is going to be used. X squared plus 2x plus 1 is x plus 1 squared. So I have the integral of 1 over x plus 1 squared. So if I let u be x plus 1, du is dx. Once we get it into this form, we can see 1 over u squared du, and it works out real well. So this is going to be u to the minus first power, and that times negative 1. So this is negative 1 over u plus c, or negative 1 over x plus 1 plus c. I'm assuming that by the time you're in calculus, you know the negative sign in front of the 1, or in front of the whole denominator, all mean the same thing. When I teach freshman math, students would argue about where to place negative signs. And it doesn't matter. Okay, now f of x equals sine x cubed. Find the integral of sine x cubed dx. So we're going to use the trig identity that the sine square is 1 minus the cosine square. It's usually written sine square plus cosine square equals 1. Of course, I just solved that with sine square here. So I have the integral of 1 minus cosine square times sine x. So I'm going to let u be cosine x. Du is negative sine x. So now I have the integral 1 minus sine 1 minus cosine squared x sine x dx. Need a negative sign, so I'll have my negative sign here. Here's my du sine x dx, and so this is u 1 minus cosine squared. Now, this is going to be a negative u, bring the negative sign in, plus u cubed over 3, and negatives here make a positive, plus c, or negative, what is u? Cosine x plus 1/3 cosine x cubed plus c. Okay, so we have all sines, and we need sines and cosines, so the trick is to use a trig identity. Okay, now we have f of x equals x cosine x squared plus 2x plus cosine x squared plus 2x. We're going to want to find the integral of x cosine x squared plus 2x plus cosine x squared plus 2x dx. If you want parentheses around the whole, it's okay, but the integral symbol and the dx imply them. So we're going to let u be x squared plus 2x, and du is 2 times x plus 1. So 2x plus 2 is 2x plus 1 dx. So now what happens is I factor this x cosine x squared plus 2x times x plus 1. And so I have the cosine here of u, and the x plus 1 goes here with the du. I need a 2, so I'm going to divide by 2, because I'm doing the 2 over 2. 2 would go into here, division by 2. And so now I want the integral of the cosine of x, and that's going to be the sine x over 2 plus c, or the sine x squared plus 2x over 2 plus c. Okay, this one is fun. Let's look at it. We have f of x equals x cubed times the square root of x squared plus 1. On the integral of x cubed, x squared plus 1 dx. You may want to think about it a few minutes, and I'm going to tell you the problem in just a minute. The problem is a lot of students are going to want to look at this and see a du. Well, it's there, but it's hidden. This x cubed is part of du, the x part. So if I let u be x squared plus 1, du is 2x dx. So, well, what do I do with the other x squared up here? Well, if u is x squared plus 1, u minus 1 is x squared. So sometimes you have to adjust the relation between x and u. And this causes difficulty. I remember teaching calculus and getting to problems where you don't get the u, but you get an expression for x in terms of u. So I have u minus 1 times u to the 1/2 over 2, the integral of that du. Well, this is u to the 1/2 times u to the 3/2 minus u to the 1/2 over 2, which is u to the 5/2, and that'll be over 5/2, but I already have the 2 in the denominator, which will cancel. And u to the 3/2, excuse my uh, equation editor, I typed them the same and adjusted this one. Over 3, the 2's will again cancel, plus c. And so now I'm going to substitute back to x squared plus 1. So I got x squared plus 1 to the 5/2 over 5 minus x squared plus 1 to the 3/2 over 3 plus c. As I said, you never know what algebraic technique, and it may not be something that you are thinking about doing. Here, breaking that x cubed down, that doesn't seem to be something we would intuitively do. And finally, another trait problem, f of x is tan x plus sine x. So we're going to find the integral of tan x plus sine x. One trick that is often used when working with trig functions is to take the functions and re-represent them as sines and cosines. So if I'm looking at the integral of tangent x, which is sine over cosine, plus sine x dx, I have something I can factor out, and that's sine x times 1 over cosine x plus 1. So if I let u equal cosine x, du is negative sine x. So the integral of sine x, 1 over cosine x plus 1 dx, is negative, and I got to think of this as a multiplier of a negative 1. I can either think of it as minus 1 to negative 1 times negative 1, or negative 1 over negative 1. I'm going to have one negative left over. This is 1 over u plus 1, which is negative the logarithm of u minus du, bringing the negative sign through, plus the constant of integration, or the negative logarithm of the absolute value of the cosine of x minus the cosine of x plus c. Please consider subscribing to this channel, and I appreciate your attention to the video. I also would like to know if any of you feel inclined to let me know in the comments if there is a need for practice calculus problems. I'm trying to figure out what people need to make the videos more relevant. Thank you.